What if I told you that almost 3/4 of the universe is made of something we can't see, touch, or directly detect? Something so strange it's actually pushing galaxies apart faster and faster, and that without it, the very structure of space would behave completely differently. Sounds like science fiction, right? Well, it's real. We call it dark energy. Today, I'm going to tell you what we think it is, how we discovered it, and why it could determine the ultimate fate of the cosmos. So lean in, because this one's wild. You, me, the planets, the stars, every galaxy we can see. Together, that's only about 5% of the universe. Another 27% is dark matter, which has gravity but no light. The rest, about 68 to 70%, is dark energy. It's not dark like a black hole. It neither swallows light nor reflects it. Light just passes right through it, as though it's not even there. Here's what makes it bizarre. Rather than pulling things together like gravity, it pushes them apart. For most of the 20th century, astronomers believed the expansion set off by the Big Bang was slowing down under gravity's pull, like throwing a ball into the air and watching it slow before falling back. But in 1998, two separate teams decided to check by observing a special kind of stellar explosion, Type 1a supernovae. These are insanely bright events, brighter than entire galaxies for a short time. Best part? Their peak brightness is predictable, like identical cosmic light bulbs scattered across the universe. Measure how faint they look, and you know their distance. Pair that with redshift, the stretching of light as space expands, and you've got a kind of speedometer for the cosmos. Now here's where the plot twists. Both teams found something no one expected. Instead of slowing, the universe's expansion is accelerating. Imagine throwing that baseball and it doesn't just keep going, it starts speeding up on its own. They were so stunned, they triple-checked the math before daring to publish, but the result held. And in 2011, the leaders of those teams were awarded the Nobel Prize in Physics. The mysterious driver of this acceleration was given a working name, dark energy. Still with me? Good, because now it gets even stranger. Scientists have a few guesses about what dark energy might be. First, Einstein's cosmological constant. He originally added it to his equations to keep the universe static, later calling it his biggest blunder. Ironically, it fits perfectly if we think of it as a constant energy density in empty space. The weird part is that unlike matter, it doesn't dilute as the universe expands. More space just means more total dark energy, which speeds expansion. Second, quintessence. No, not the mystical kind. This is a hypothetical energy field that can vary across space and time. Third, maybe gravity itself isn't quite the way Einstein described at the largest scales. A modified gravity theory could mimic the effect we're blaming on dark energy. Now, here's a mind bender. Try using quantum physics to calculate how much vacuum energy should exist, and you get a number outrageously too large, about 120 orders of magnitude bigger than the real value. It's the worst mismatch between theory and observation in science. So why should you care? Because dark energy is steering the future of everything. Picture this. If it stays constant, galaxies will drift away so fast that one day their light will never reach us. The night sky will grow empty until we see only the Milky Way and our nearest neighbors. Or if its strength grows, we could face the Big Rip. Expansion so violent, it tears apart galaxies, stars, planets, even atoms. And here's the thing, we can't see it directly. We detect it by watching how the expansion changes and how the light from distant objects stretches. We also study the large-scale structure of the universe and the faint afterglow of the Big Bang, the cosmic microwave background. Future tools, like NASA's Roman Space Telescope, will map billions of galaxies to track how dark energy shaped the cosmos over time. Imagine standing on a beach and watching the tide. Now imagine not just the tide, but the entire ocean rising faster and faster with no visible cause. That's what dark energy is doing to space itself. Of course, not every scientist agrees it's real. Some suggest the acceleration is just an illusion caused by the universe's structure, cosmic voids and dense clusters affecting how time passes and light travels. But the bulk of the evidence still points to something, whatever it is, pushing on the fabric of space. So here's where we are. Dark energy makes up most of the universe. It's invisible, it's mysterious, and it's the main driver of cosmic destiny. And right now, no one can tell you exactly what it is. But maybe, someday, we will. Maybe we'll find a new particle, a twist in the laws of gravity, or discover something so unexpected it forces us to rewrite physics from the ground up. Until then, remember this. When you look up at the night sky, most of what's shaping the fate of the cosmos isn't the stars you see. It's the invisible hand of dark energy, silently rewriting the future of everything. And here's the challenge I'll leave you with. Next time you hear the words empty space, picture it not as nothing, but as a restless sea of energy, expanding, pushing, reshaping the universe itself, and one day potentially deciding how it all ends.